Well, hello again, guys. This is well, kind of impromptu video, but we're also going to do something that I've got a couple requests on too. But first to the impromptu part, and I went today. I've been out of town and went and bought me another radio, and well, I'll just show you what it is. It's sitting right here. It's an Atwater Kent model 67. Now these were battery operated radios. I haven't checked the tubes. Most of them are globe tubes except for the RF tubes here. Of course she needs cleaning, but that's all she really looks like is going to need cleaning. I haven't spotted any actual rust anywhere, so hopefully the tubes are good and everything. I'll be checking them later. These are your battery cable hookups. It's got one broken one here, but I got the two halves for it, and of course it's got the label telling you what voltages. I have a power supply it's a battery eliminator that's Atwater Kent, and I believe it will produce every one of these voltages. Hopefully it does, because I hate to come up with, well, 180 volts. That'd be, well, you're basically looking at 29 volt batteries, and 9 volt batteries aren't cheap, so I really don't want to do that. Now it does happen to have the C batteries in it, which probably are dead. I doubt there are any life in them, but I found it interesting. They actually have not leaked. They're looking in good shape. It has the connection, how you connect them up and everything. But I found that rather interesting that they were still in there. The speaker, the Type F-7 speaker, and as you can tell, other than being just a slight little warpage here, it's in good shape. It moves good without making any sounds. In fact, the only thing I can find wrong with it is these two wires here have broke loose from here. That's really a minor issue, but otherwise she's in really not bad shape. Looks like it's slightly bent here for some reason, although when it was in the radio it didn't look that way, or in the cabinet. And here's the cabinet. Now she's got a few little very minor, very shallow scratches on the top, and there's just a slight little bit of loss right here in these back corners, but I don't mind that so much when they're in the back like that. That's pretty easy to clean up and take care of. There's something that's on the surface, but it's on the surface. If you could feel it, you could tell it's whatever it is. I think it'll clean right off. But I think other than cleaning Hallard's Restore would probably just bring this thing back to beautiful there. The front is right here, and there's a little tear in the grill cloth, but otherwise the cabinet's in pretty good shape. On the front anyway, there's a few little blemishes here and there. There's just the slightest bit of tear right here, but that may be able to be fixed. If not, that don't look like that. If that, and I think it is original from some of the pictures I've seen, trying to replace something like that probably won't be that hard. Otherwise, in pretty good shape. Now that's the good parts. The bad parts are on the sides here. There's just a little bit of, up to about right in here, separation. But it's not bad. Not bad at all on both sides. It's almost like it'd been wet. And we've lost one little bit of piece of wood here on the turns, but that's not that difficult to fix either. So I don't think the cabinet will be that hard to work on. I've got the top plate that goes on top of the radio sitting in here. That goes over top of the tuning condensers. But otherwise, of course, it's dark in here, and I should have brought a flashlight, but she's not too bad of shape. She's pretty solid. So, but I thought I'd show that to you. Now, the interesting thing about it, I paid the whole of $25 for it. So, that's all it cost me. So, I think it'll be a fun little project to do and get all cleaned up. Now the front here, it's got a little blemishes here, and I don't know if you can see it, but the outline is right here where it shows through the cabinet. So this is actually was up against the cabinet here. So it's not too bad. Now, on to other stuff. I'm just going to leave this set here because it's rather heavy. Now, one of the little requests was to deal with a little more on, less on the scope, more on the generators. The two sweep generators I got in here, how they're connected up, how they're used, and stuff. So anyway, this here is a pulse marker sweep generator. It's a Knight KG687, but it's virtually the same as pretty much any of them of the era. What you have, this is your sweep frequency. This here picks different ranges from up as high as 220 megahertz down to band E, which is as low as 3 megahertz. You have your sweep width, which gives you how wide the sweep's going to go. So I mean, if you pick, like right now I got it centered on 24 megahertz. I believe about right here is about 5 megahertz sweep width. So about 2.5 megahertz either side, or pretty close to that. Get those out of the way. This dial here is your marker dial, and this switches it to where you want to be at on your markers as accordance to where you want to be at here. I guess I'm on the other band here. It's not actually on 24. It looks like about 10.5 megahertz, but this adjusts your marker, and in most of these, this is usually not too much of adjustment that you can make as far as aligning the generator itself. These kind of float but this one here, the marker, they usually have adjustable coils to set them so that you can set the marker so it's dead accurate, and then you just let the marker determine the frequency on this as much. You take your dial and you just basically get it in the general area, and then you look for it in the marker. It does have a crystal that will add to accuracy and add to harmonic frequencies. These two will mix, creating harmonics, so you can have more markers. This one happens to be 4.5 megahertz, so it'll give different values, different multiples, both of this one as well as a mixture of the two. And of course, you have your coarse and fine level control, which is your attenuator. This one also has a bias voltages that, because on some, especially TVs, you might want to put in, generally you do put in a bias voltage in to shut off the automatic frequency control, and so it's not fighting you. So both these go up to minus 20 volts, and of course you got the marker size here. the connections for it is you got, which I should have moved the cables, you got your standard RF. Now this is going to be the input to the radio, and I've got right now, we're just tied across to the D-Mod. So there's obviously no radio in here, so the two are just connected together. But where this connects on, your RF out, will be more dependent on your instructions for your alignment instructions, where they want you to hook it up. Generally, you hook these up, usually around the mixer tube, usually the grid of the mixer tube. And that I want to bring up something, because I've noticed some people on other videos sometimes get mixed up about that. Let me bring up on here a tube manual. Here's a 6A8. This is a typical older mixer tube that would have a top cap on it, and that's your control grid. Your control grid will always be this grid right here, between these two grids here that come off of pin 4. It's not the first grid. This grid here, right in this point, this one here, it goes to the oscillator if the tube's being used as an oscillator. So, which usually a lot of times they do. So these two, this acts as a plate for the oscillator. This one here, coupled with this one, acts as the cathode. Even though it does have a positive voltage, it's less than this voltage. It'll act more like the cathode for the rest of the tube, and this allows this to be the control grid. And we're one other way of knowing this, generally, here's the other RCA radio, and it's I apologize for it not being too good, but there's that grid right there coming out, and there'd be a cap. But they usually connect to the tuning condenser and the antenna coil. That's where the signal comes in and goes there, and that's where you would be connecting on most radios for doing, especially doing the IF. You'd be connecting that RF cable here. Now, these two cables, you got horizontal and vertical. They go down to the scope, which I got turned down right now, and that's where they go to. Which for some reason I'm not getting a signal showing up. But anyway, they go down here and they hook into here, and so you get a sweep on here. And then the other cable you will have is a D-Mod probe. This is what you're going to be picking up this signal from the RF. And this one generally will connect, when you're doing at least IFs, generally, not always, and like I say, you need to go by the instructions to get to your radio, but generally will connect in the secondary circuit, of the second IF circuit somewhere, usually around like a point right here. And of course the grounds just go to chassis ground, both the RF and the D-Mod, but the hot lead generally will connect here. So you send the signal in here, goes through the IFs, comes back out here, and goes back to the generator, which then in turn sends it down to the vertical. And that's how those are really hooked up. The big, the big thing about these is that you've got two leads here that go to the scope, and the RF goes to the radio, D-Mod goes to the radio, nothing goes to the scope except the generator itself. These are, excuse me, known as post marker generators, meaning that the marker is added in with this signal here coming in to the radio. It's added in after the signal has been sent through the radio. Now, the other type is like this, of sweep generators. This, you just have an RF line, and it connects in the same place as this one would. But the difference is you don't have no scope probes that's going to go to the scope. Instead, you'll take your DMOD probe and you'll hook it to the scope and hook that to the radio. And so this sends in the signal. The DMOD probe will pick it up and send it to the scope. And that's how these work. Now, to get a marker in there, there's only two ways of doing it. One is with a crystal. You can actually put a crystal in here of the size of the frequency of what marker you want. Back in the old days, back in the days when these things were built new, a lot of guys would just, they'd buy a whole like cabinet like this that have several different crystals in it, several different frequencies, and you just plug in whatever crystal. Like if you're doing 455 kC, you want to know where the center is, so you'd plug a 455 kC crystal in here, and it would create a marker that's right on that center frequency. Otherwise, you take a generator like this and you connect its output to this here with a capacitor connected to them. Run this through a capacitor to this output going into the radio, and generally somewhere from between 100, maybe even 50 picofarads up to 1,000 picofarads. You just kind of got to play with. I found that with this signal generator here and this one, around 100 picofarads work about the best. And then you just adjust this. Now the nice thing about it, this is variable, where the crystal would be solid, where this is variable. So with it being variable, you can kind of float around, and try to find out exactly how far you're off on a marker, or maybe something that you're working on. Maybe you want to have a couple markers or something there. At least you can move them around and find them. But I hope this answers your questions. The big difference between these two is how they hook to the scope. This one here is actually hooked to the scope. This type is not. And the other difference is how the marker is generated and how it's put in. This is put in after the signal has went through the radio. This is put in before the signal goes through the radio. So that's really the two main differences. Now, as far as we keep talking about demodulation probe, this is what the schematic of one kind of looks like. It's just this lower part down here. A 1N60 diode. Those are hard to find. The rest of the parts are easy. You got like a 0.01 capacitor, 1,000 picofarad capacitor, a couple 100K resistors. As far as getting that there, the 1N60 diode, a 1N34A you can find. There's some places that sells those. Or the next closest thing is the, I think it's NT, or I believe is the letters, 109. You can pick those up at Radio Shack. They're all just germanium diodes. And so crystal diodes, so that you can pick those up. Now, I know this is not coming in real good, but if you go on Google and do a search for DMOD probe schematics, say ICO. ICO is very similar to this. ICO actually had a schematic for one just exactly like this one here. This is a leader. You can find it on there, and you can download that and then print it off, and you'll have a schematic if you want to make one. Otherwise, you can buy them. This is a demodulation probe probe for a scope. Test Tech demodulation. But these run, they're 60 bucks is what they are. HP makes one, that company makes one. There's about the only two companies I know of that makes them. And they're $60. So if you build your own, all you need is some cable, like RG58U cable, some 50 ohm cable, of course naturally a connector, and there's what, you got 5 parts in there, and that's it. And then you just use test leads, clip leads like this is using, and you can just build that up. And if you go like the Radio Shack, you can also get you a little job box about the size of this, or you can put it in any number of different type of containers. It don't have to be shielded. This box is not shielded at all. So, but you can build one up and make your own probe, probably $10–15. So it's it's a lot cheaper than buying one of these, unless you want to buy one. But that's about all there is on sweep generators. Like I say, now as far as the radio hookup, that's generally going to be in your instructions, alignment instructions. So you want to use those, or you want to try to find those, because some of these radios, I haven't looked at this one, but some radios want you to just say this IF can here, they want you to feed the signal here and not back here. Once this was adjusted, then you'll adjust this one, and they want you to feed the signal here to adjust that one. Other radios, you just feed it in one spot, take it out the other spot, adjust both IF cans, and call it good. So they vary. That one radio FM I was playing with, that I was showing you guys, it was like what I just said, where they want you to feed it in right by the IF. It had 3 FM IFs, so it wants, feed the first tube nearest the last IF can, so that, and feed it there, and then move down the line and keep moving down the line until you end up at the mixer doing the very first IF can. Of course, always when you're doing IF alignment, you always start the closest to the audio end and work your way back. So, but anyway, that's basically it. When I get finished with this radio here, which is setting right here, I got a start on it, and the next video will be on this. When it gets done, we'll do the alignment, and I want to do the alignment both visually with a sweep generator. It'll probably be this one, because this does not go down to 455, so I'll be using this one here. And then I want to show you another technique of using just a VTVM, and how you do that. So that's probably about it. So thanks for your comments, thanks for watching, and thanks to all my new subscribers. Hope you guys had a wonderful Thanksgiving and didn't eat too much, or if you did, you got rested up pretty good. So on the next one, we'll be looking at this is the other RCA 6K/6T, which I actually think it's a 6T because of the speaker cord I don't think it's long enough for a console cabinet. That's what the 6K goes in. I think this is actually a Cathedral radio, but they're the exact same chassis. So, and then at some point we'll work on this and see where we can get with this. So I better get off here. We're about out of time. So thanks again, and be looking forward to future videos after this one. Bye.